Deciding whether to start an electrical contracting business as a franchise or independently involves weighing several factors. Firstly, let's consider the franchise model. A franchise offers a proven business model, established branding, marketing support, and training programs. However, this comes at a cost. You'll be required to pay ongoing fees and have less control over business decisions. Secondly, let's look at the independent model. An independent, or own system approach grants complete control over operations. This allows for flexibility and customization, but it demands significant upfront investment in marketing, branding, and overall business development. Focusing on the Mr. Electric franchise, there are both pros and cons to consider. One of the pros is brand recognition. Mr. Electric is a well-known and established electrical franchise which can provide an immediate advantage in attracting customers. Another pro is marketing support. The franchise typically provides marketing materials, advertising campaigns, and an established online presence to aid in customer acquisition. Comprehensive training and ongoing support from the franchisor is also a pro. This can be particularly beneficial for those new to business ownership or specific aspects of electrical contracting. Further, Mr. Electric has a large customer base that can provide referrals, generating leads and potentially reducing marketing expenses. On the other hand, there are also cons associated with the Mr. Electric franchise. Franchise fees are a major consideration. You'll be obligated to pay an initial franchise fee and ongoing royalties, which can impact profitability. Another con is limited control. Franchisees must adhere to the franchise's rules and procedures, potentially restricting innovation and customization. There can also be competition from other franchisees. Mr. Electric may have multiple franchisees in the same geographical area, leading to competition for customers. The franchise requires a substantial investment in equipment, vehicles, and marketing, which can be a barrier to entry for some. Experiences from other Mr. Electric franchisees vary. Many have reported positive experiences, citing the strong support system and effective marketing efforts provided by the franchisor. However, some franchisees have mentioned challenges such as high overhead costs and competition from other franchisees within their territory. Training quality has also received mixed reviews, with some franchisees praising the comprehensive training while others have found it lacking in certain areas. Making the decision between starting your own electrical contracting business or joining the Mr. Electric franchise depends on your individual goals, circumstances, and risk tolerance. If you value brand recognition, marketing support, and structured guidance, the Mr. Electric franchise might be a suitable option. Conversely, if you prioritize complete control over business operations and are prepared to invest the time and resources to build your own brand from the ground up, starting your own business might be more appealing. Regardless of which path you choose, certain additional considerations are crucial for success. Market research is essential. Conduct thorough market research to evaluate the demand for electrical services in your target area and to assess the existing competition. This research should identify potential customer segments, pricing strategies, and service gaps in the market. You should also develop a comprehensive business plan. A well-structured business plan is vital for securing financing, guiding operations, and tracking performance. The business plan should include a market analysis, competitive assessment, marketing strategy, financial projections, and operational plan. Securing adequate financing to cover startup costs and ongoing expenses is also important. Explore various financing options such as small business loans, lines of credit, and investment capital to ensure you have sufficient funding to launch and sustain your business. Finally, obtain the necessary licenses and certifications for electrical contracting. Ensure you meet all legal and regulatory requirements for operating an electrical contracting business in your specific jurisdiction. This includes obtaining the appropriate licenses, permits, and insurance coverage. The NEC, or National Electrical Code, is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. Understanding and adhering to the NEC is critical for any electrical contractor. The NEC is updated every 3 years, so it's essential to stay current with the latest revisions. Here are some specific NEC articles that are particularly relevant to electrical contractors. Firstly, Article 110.14 covers electrical connections, ensuring proper termination and installation of conductors. Secondly, Article 210.12 deals with arc fault circuit interrupter protection, requiring arc fault circuit interrupters in dwelling units to prevent electrical fires. Thirdly, Article 250.122 addresses equipment grounding conductors, specifying the size and installation requirements for grounding conductors to ensure safety. Fourthly, Article 300.4 focuses on protection against physical damage, requiring electrical wiring to be protected from physical damage to prevent shorts and other hazards. Fifthly, Article 310.15 outlines conductor ampacity, determining the maximum current carrying capacity of conductors based on their size, insulation, and installation method. Sixthly, Article 406.4 covers receptacles, addressing the installation and grounding requirements for receptacles to prevent electrical shock. Seventhly, Article 408.36 pertains to overcurrent protection, specifying the requirements for overcurrent protection devices such as circuit breakers and fuses to protect electrical circuits from overloads and short circuits. Eighthly, Article 430.52 focuses on motor circuit protection, requiring specific overcurrent protection for motor circuits to prevent motor damage from overloads and short circuits. Ninthly, Article 517.13 addresses healthcare facilities, providing additional safety requirements for electrical installations in healthcare facilities to protect patients and staff. And tenthly, Article 547.5 covers agricultural buildings, addressing the specific electrical needs and safety requirements for agricultural buildings, including protection from moisture and corrosive environments. Let's delve deeper into some crucial electrical concepts. Voltage, measured in volts, represents the electrical potential difference that drives current through a circuit. In residential settings, typical voltages are 120 volts for lighting and small appliances and 240 volts for larger appliances like ovens and dryers. Commercial and industrial settings often utilize 208 volts, 277 volts, and 480 volts for various equipment needs. Understanding voltage is fundamental for selecting appropriate wiring, equipment, and safety measures. Current, measured in amps, is the flow of electrical charge through a circuit. The amount of current flowing through a conductor determines the heat generated, and exceeding the conductor's ampacity can lead to overheating and fire hazards. Circuit breakers and fuses are overcurrent protection devices designed to interrupt the current flow when it exceeds a safe level, preventing damage to wiring and equipment. Resistance, measured in ohms, opposes the flow of current in a circuit. Every electrical component, including wiring, has some level of resistance. High resistance can lead to voltage drops and reduced efficiency, while low resistance can result in excessive current flow. Understanding resistance is essential for troubleshooting electrical problems and ensuring efficient operation of electrical systems. Ohm's law, expressed as volts equals current times resistance, is a fundamental principle that governs the relationship between voltage, current, and resistance in a circuit. This law is essential for calculating voltage drops, determining current flow, and designing electrical circuits. Power, measured in watts, is the rate at which electrical energy is transferred. Power equals volts times amps. Understanding power calculations is crucial for determining the energy consumption of electrical devices and systems, selecting appropriate wiring and circuit protection, and managing energy costs. Grounding is a critical safety measure in electrical systems. Grounding provides a low impedance path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock hazards. Grounding systems must be properly designed and installed to ensure effective protection. Wiring methods encompass the various ways electrical conductors are installed and protected. Common wiring methods include non-metallic sheet cable, also known as Romex, electrical metallic tubing, also known as EMT, rigid metal conduit, and flexible metal conduit. Each wiring method has specific applications and installation requirements based on the environment and type of wiring. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the current flow when it exceeds a safe level, preventing damage to wiring and equipment. Selecting the appropriate overcurrent protection device is crucial for ensuring safety and preventing nuisance trapping. Electrical boxes, also known as junction boxes, are enclosures used to house electrical connections and protect them from physical damage. Electrical boxes must be properly sized and installed to accommodate the wiring and devices they contain. Different types of electrical boxes are available for various applications, including surface mount boxes, recess boxes, and weatherproof boxes. Conductors are the wires that carry electrical current. Conductors are typically made of copper or aluminum and are insulated to prevent short circuits. The size of the conductor determines its ampacity or current carrying capacity. Selecting the appropriate conductor size is essential for ensuring safe and efficient operation of electrical circuits. Electrical codes and standards, such as the National Electrical Code, provide guidelines and requirements for safe electrical installations. These codes and standards are developed by organizations such as the National Fire Protection Association and are updated regularly to reflect changes in technology and best practices. Adhering to electrical codes and standards is essential for ensuring safety and preventing electrical hazards. Electrical safety is paramount in all electrical work. Always de-energize circuits before working on them and use appropriate personal protective equipment such as gloves and safety glasses. Follow lockout-tagout procedures to prevent accidental energization of circuits. Be aware of potential electrical hazards such as exposed wiring, damaged insulation, and wet environments. Never work on electrical equipment unless you are qualified and trained to do so. Electrical troubleshooting involves identifying and resolving electrical problems, such as power outages, short circuits, and faulty equipment. Troubleshooting requires a systematic approach, including visual inspection, voltage testing, and continuity testing. Use appropriate test equipment such as multimeters and circuit tracers to diagnose electrical problems. Electrical maintenance involves performing routine inspections and repairs to ensure the reliable operation of electrical systems. Maintenance tasks include inspecting wiring, tightening connections, testing overcurrent protection devices, and replacing worn or damaged components. Regular maintenance can prevent costly repairs and extend the life of electrical equipment. Energy efficiency is becoming increasingly important in electrical systems. Energy-efficient lighting, appliances, and motors can significantly reduce energy consumption and lower electricity bills. Consider using LED lighting, Energy Star-rated appliances, and variable frequency drives for motors to improve energy efficiency. Renewable energy sources, such as solar and wind power, are becoming more popular as alternatives to traditional fossil fuels. Installing solar panels or wind turbines can reduce reliance on grid electricity and lower carbon emissions. Consider the feasibility of incorporating renewable energy sources into electrical systems. Smart home technology is revolutionizing the way we control and manage our homes. Smart home devices, such as smart thermostats, lighting controls, and security systems, can be controlled remotely via smartphones or other devices. Consider incorporating smart home technology into electrical systems to improve convenience, energy efficiency, and security. Electrical inspections are conducted by qualified electrical inspectors to ensure that electrical installations comply with codes and standards. Electrical inspections are typically required for new construction, renovations, and repairs. Addressing any deficiencies identified during an electrical inspection is essential for ensuring safety and obtaining approval for the electrical work. Electrical permits are required for many types of electrical work, such as new installations, major renovations, and service upgrades. Obtaining an electrical permit ensures that the work is inspected and complies with codes and standards. Failing to obtain an electrical permit can result in fines and delays. Electrical contractors are licensed professionals who are qualified to perform electrical work. Electrical contractors have the knowledge, skills, and experience to design, install, and maintain electrical systems. Hiring a qualified electrical contractor is essential for ensuring that electrical work is performed safely and correctly. Continuing education is important for electrical contractors to stay current with the latest codes, standards, and technologies. Continuing education courses cover topics such as new electrical codes, energy efficiency, renewable energy, and smart home technology. Participating in continuing education can enhance skills and improve knowledge. Professional organizations, such as the Independent Electrical Contractors and the National Electrical Contractors Association, provide resources, training, and networking opportunities for electrical contractors. Joining a professional organization can enhance credibility and provide access to valuable industry information. Business management is an essential skill for electrical contractors. Business management tasks include estimating costs, bidding on projects, managing finances, and marketing services. Effective business management can improve profitability and ensure the success of an electrical contracting business.